A geometric series is any series that we can write in the form of a plus a times r plus a times r times r plus a times r times r times r equals the sum of n equals 1 to infinity of a times r to the n minus 1. Now, what does this really mean? Simply put, this means that each term after the initial term is found by multiplying the previous term by r, where r is our common ratio. So let's draw an example here.
1 plus 2 plus 4 plus 8.
Our initial term a equals 1, and our common ratio r equals 2, where every single time after our initial term, we are multiplying the previous term by our common ratio. Now, this is the entire idea of what a geometric series is. For a series to converge, it needs to come to 0. And for that to happen, we need our common ratio r to be bigger than -1 or smaller than 1. Or mathematically put, and this makes sense intuitively based on the following example I'll show you. Let's take a equals 1 and r equals 1/2. You'll see that each term gets smaller and smaller. 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16, etc. As you can see in this example, this will converge to 0 as each term gets smaller and smaller. And the formula for this specific series would come out to and as you can see here, this definition of a geometric series, remains consistent. So now let's talk about how to find the formula to calculate a convergent geometric series. The series will always converge with this formula. Here, a still equals the initial term. And r is still the common ratio. Now, I like to just first draw out a few of the first terms. So here we have So we see here that 1/5 plus 1/25 plus 1/125 equals, and now I need to figure out what our common ratio is and our initial term is. So it's pretty clear here that our initial term, is 1/5, and our common ratio is also 1/5. Okay, so now we can go back to our formula of geometric series, our a times r to the n minus 1, and we see that we have 1/5 times 1/5 to the n minus 1, running out of space there. Okay, so now we get to determine whether or not this series is convergent. We know it is based on just, eyeball test. We can see that the terms are getting smaller and smaller, and will go down continually. And we also know this based on our previous definition of whether or not a geometric series is convergent, because the absolute value of r is smaller than 1. Okay, bingo. So now we can solve our convergent series. And we can use the formula that we talked about in the last section, which is a over 1 minus r, which in this case equals 1/5 over 1 minus 1/5, which equals 1/5 over 4/5, which equals 1/5 times 5/4, which equals 1/4. In order to transform this function to a geometric series, we need to remember our initial formula for a geometric series. And it goes as follows. As you can see, our function is already in a pretty similar form to our formula. And we can make that conversion right now. Let's say that x is a. Okay, let's subtract 1 from our 2 here, so we fit this same shape. And instead of r, we'll do x. And then remember, we're going to have to add that 1 back. In other words, fits the same exact form as our formula above, where x is our a and x minus 1 is our r. Now back to our original definition of what makes a geometric series convergent. The absolute value of r being smaller than 1. The same thing applies here. We can plug in x minus 1.